So today we're going to be talking about prime numbers and how to find the greatest common factor and the least common multiple. So there's a bunch of different ways that you can factor to find the prime factorization or to determine if something's prime or composite. So we're just going to kind of review some basics here and make sure we have an understanding of what this means. So prime number means only one in itself can multiply to give you that number. Composite means there's more than one in itself. Alright, so the first thing we're going to do here is determine if these numbers are prime or if they are composite. So let's take a look at our first example, 36. So we want to write its factors out. 1 and 36, 2 and 18, 3 and 12. Using a calculator can make this really easy. Then 4 times 9. And 6 times 6. So if we want to know the number of factors, we need to add up all the unique values there. So we wouldn't count 6 twice. So that means we would have 9 factors with this problem. Alright, so let's take a look at 17 and see what we can come up with here. So looking at 17, we know 1 and 17 multiply to give us 17, but do not think there's anything else. So that makes this number a prime number. Alright, so C is a 1. So 1 times 1. That's it. Now this is kind of a special case. It is considered not prime because it doesn't have 2 unique factors. It's just a 1. So 1 is not prime. Alright, so the last one there is 65. So we need to think of all things that multiply here with 65. 1 and 65. 2 doesn't, 3 doesn't, but 5 does. 5 times 13. So that makes this now as 4 factors, and it makes it a composite since we have more than 2 unique factors. Alright, so we're going to be talking about prime factorization next, and we've all done this before. So this is just writing out a number using all of its prime factors. So it's pretty easy to do, especially with the calculator. It may take a little bit more time doing it by hand. So let's take a look at these 3 examples. So 72. I'm going to use the factor tree method. It's totally up to you how you want to do the prime factorization. I'm going to start off and say it's even. So I'm going to divide 72 by 2. So that's 2 times 36. 36 is even. So I'm going to divide it by 2. I get 2 times 18. 18 is even. So I'm going to divide it by 2. And I get 9. And well, 9 has factors of 3 and 3. So there we have the prime factorization. So we can write this out as 2 times 2 times 2 times 3 times 3, or we can write it as 2 cubed times 3 squared. Alright, so the next example, 23, when we go to try to do prime factorization with that, you probably notice that it's only 1 times 23. So since it's prime, we can't make a factor tree out of it really. So now 180. So again, same thing, it's even. So let's just keep dividing by 2 as long as we can. 2 times 90. 90 is even, divided by 2. 2 and 45. Alright, now right here, I know that the 45 is divisible by 3. So we should move up to a 3 and do 3 times 15. And 15 we can do 3 times 5. So now we can write our prime factorization out. And a quick reminder on how to tell something's divisible by 3 if you add up its digits. So like 45, 4 plus 5 is 9. 9 is divisible by 3, which means 45 is divisible by 3. It's kind of a quick way to check that. Alright, so let's do a bigger number here. So the prime factorization is 6,552. So again, it's even. So we want to start off by breaking it apart with the 2. And we get 3,276, even again. Let's just keep dividing by 2. Alright, so keep going by 2 again. Alright, so now we have to find what it divides into. So again, using that rule, I know 3 divides into it, because 9 plus 9 is 18. 8 plus 1 plus 9 is 18. This is 273. Looks like I'm going to run off the screen a little bit here. So 3 and 91 make 273. Then 91 does, so 7 times 13. I had to do a little guessing on the calculator to figure that out. So here's the prime factorization. We can write it all out. And we could write it as 2 cubed times 3 squared times 7 times 13 if we wanted to. Alright, so the greatest common factor is just the biggest number that divides into both of your terms. And then the least common multiple is the smallest integer such that is a multiple of both a and b. So we'll see what those look like here in our next examples. Not really that difficult to do. Alright, so we have our methods here to find them. So one thing to do for greatest common factor would be just to do the prime factorization and see what they have in common, and that would be your greatest common factor. And then your least common multiple, using the prime factorization, you take the largest power of each prime that is in either one of those two numbers, and you multiply those all together. So let's take a look at an example here. Alright, so let's find the GCF of 36 and 40. So we're going to do the prime factorizations of each one of them and see what they have in common. So 36, hopefully you look at that and go, well, it's even, so I can divide it by 2. So it's 2 times 18. Well, 18 is 2 times 9, and 9 is 3 times 3. So that's our prime factorization. 40 would be 2 times 20, but 20 is 2 times 2 times 5. So now we say, what do they have in common? So looking at this, it looks like they both share 2 2's, right? So our greatest common factor in this situation would be 2 times 2, which is 4. Alright, so if we want to find the least common multiple, we have to see what the biggest power of each that they have in common. So if we look at the 2's, 40 has 3 2's, so we have a 2 cubed in our least common multiple. And then we look at the 3's, 36 has 2 of them, so we have to put a times 3 squared, so I'm color coding it for you. And then we just have that 1, 5, and 40, so we're going to have to tack that on. So that's where all those numbers came from. And then we should just go ahead and multiply them out if somebody wants to know what the least common multiple is, and we get 360. Alright, so now we're going to do the same thing with B. Let's find the greatest common factor. So we're going to do the prime factorizations of 20 and 27. Well, 20 is 4 times 5, which is really 2 times 2 times 5, right? So that's the prime factorization. 27 is 3 times 9, but 9 is 3 times 3, so really it's 3 times 3 times 3. So notice these two numbers do not have any common factors, so that means their greatest common factor is 1. Alright, so now let's do the least common multiple. So we're going to go through and say how many 2's, biggest number of 2's, and so on. So notice we have 2 2's, so we'd have a 2 squared there. And then we go through, alright, we got 3's in the problem as well. So we'd have a 3 cubed, 3 3's. And then we have our 1 5. And then we can multiply those out and find our least common multiple. Alright, 540. So now, let's take a look at this one here. So this one's already got it in prime factorization. So our greatest common factor here is just what they have in common. So if we go through and look at this, we say, well, what do they share? They share 3 2's. I'm sorry. I'm writing now all of it out. So there's the prime factorization, that first one without all the exponents. So we're definitely going to have 3 2's in common. And then we got, looks like we're going to have 3 2's and 2 3's as our greatest common factor. Writing kind of slow. And we get 72. 9 times 8, right? So now, these common multiple. We're just going to go through and see what the biggest power of each prime number. So we have what? How many 2's should we put down there? 5. Good. And then we should have 4 3's and 1 7. So that's going to be a big number. So 18,144. Alright, so we're going to find the greatest common factor and the least common multiple. So remember, the GCF is what they have in common. So we're going to go through and look and say, well, what do these two guys have in common? They both share 4 x's. And they both share 8 y's. And that is it. So that is their greatest common factor, x to the 4th, y to the 8th. So now, when we do their least common multiple, we have to take the biggest power of each term. So there we go. So we have 7 x's. We're going to have 12 y's. And then we're going to have our w and then our 5 c's, c to the 5th. So that would be our least common multiple. Not too bad, right? Alright, so b. So b's a little different because it actually has coefficient in front. So we've got numbers we've got to factor along with this. So with that first term, 81, hopefully you're thinking 9 times 9. And well, 9 is 3 times 3. So 81 would actually factor what? 3 times 3 times 3 times 3, right? 3 to the 4th. And then 45 is what? 5 times 9, and 9 is 3 times 3, so it would be 3 squared times 5, x to the 8th, y to the 2nd. So now we look at and say what do they have in common? Well, they both have 2 3's, they both have 3 x's, and they both have 2 y's. So 9x cubed y squared is their greatest common factor. Alright, so least common multiple. So we got 4 3's, so 3 to the 4th. And then x's, we're going to have, the 5 there, forgot about that. 5. Then we got 8 x's and y to the 5th. So, man, 81 times 5 is 405, x to the 8th, y to the 5th. Alright, so let's find the GCF and the LCM of 3 different algebraic expressions. So we're going to have to approach this the same way, just do 3 of them. So let's factor 18, 2 times 3 times 3, because 2 times 9. And then we got x to the 4th, y to the 8th. Now 30 is what? 5 times 6. So that'd be 2 times 3 times 5. And a calculator would be really helpful if you have trouble prime factoring in your head. Alright, so 12 is 2 times 6. Well, 6 is 2 times 3, so that's 2 times 2 times 3. So now, their GCF is what they have in common. So let's go through and see how many 2's do they have in common. So hopefully you're looking at that and go, well, they all only share 1 2. How many 3's? Well, they all only share 1 3. And how many x's? Well, they all share 4 x's. Then how many y's? They all share 2 y's. So that's our greatest common factor, 6 x to the 4th, y squared. And so our least common multiple now, that's the biggest power of each term in our expressions. So let's start with 2's. So there are 2 2's in the bottom one. So that means we got to put a 2 squared into our least common multiple, right? Now let's look for 3's. Who has the most 3's? The top one has 2 3's, so 3 squared. So now look at the x, or nope, we got a 5 there, don't we? So we're going to have to put that 5 in there. And now x's, looks like the biggest number of x's is 7. And then y's, looks like our biggest number of y's would be 9. And then we just have to put that z there, z to the 6th. There's our least common multiple. 180, x to the 7th, y to the 9th, z to the 6th. Alright, so that's today's lesson. Have a great day. Message me with any questions you might have.